This is problem 1 on exam 2 of module 4 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1 is you have a box full of 30 microfarad capacitors and a 5-volt battery. Sketch a single circuit that meets both of the following conditions. The charge on exactly one capacitor is 5 times that of another. The voltage across exactly one capacitor is 2 volts. Label the capacitors that meet the conditions. We only have one value capacitor, 30 microfarads. To give one capacitor 5 times as much charge as another, we can put 5 capacitors in series in parallel with a single capacitor, like this. First put 5 in series, and then have 1 in parallel with those. So connecting them up, we get this. This one will have the full voltage of the battery. Each of these will have only 1 volt across it. This is 5 times the voltage. Everything is the same capacitance. It's going to get 5 times the charge. And we can calculate what the charge is. A 5-volt battery hooked up across a 30 microfarad capacitor will separate 150 microcoulombs. These are each 1 volt. They'll separate 30 microcoulombs. That's the first one. Now we have to stick a capacitor in there that's going to have 2 volts across it. How do we do this? I don't know. Let's try some stuff. What if I put a third branch in with 2 capacitors in series? The total voltage drop is 5. Each of them will have 2.5. If I put 3 in series, each will have 1 2/3, 1.67. Okay, I'm close. I got to get 2. We need a branch in which the branch is going to have a total voltage drop of 5 volts, the voltage of the battery. So we need a branch that has 2 volts across one capacitor, and then there's something else, some conglomeration of capacitors that has a voltage drop of 3 volts across it. If we had a 30 and a 20 microfarad capacitor in series across a 5-volt battery, the 20 microfarad would have a voltage drop of 3 volts, and the 30 microfarad will have a voltage drop of 2 volts, which is what we want. But we don't have a 20. We need a 20. We can make a 20. 3 30s in series will make a 10. If we put 2 of these banks in parallel, each 10, that's going to give us an equivalent capacitance of 20. So let's do this. So there's 10, 3 30s in series. There's another 10, another 330 in series. If I put these in parallel, 10 plus 10 is 20. That gives me the 20, and I want to put that in series with a 30, and I have a 30. That's the stuff that comes in the box, a bunch of 30s. Okay, so now I just got to hook all this up. Okay, I think that's it. So this, let's look at this circuit. These 7 capacitors down here. These 7 capacitors have a total voltage drop of 5 volts across it because they're across the battery. I got to remember to put the battery in. Meredith wouldn't take off any points, but Meyer would take off points if you don't put the battery in. 3 10s in series, 3 30s in series produce a 10. 2 10s in parallel produce a 20. The 20 in series with a 30. There's my 30. And these 6 make a 20. I can get the equivalent capacitance of this bottom 7 capacitors. Turning a 60 over 5 upside down, that's a 12, I think. Oh, there's my battery. Good news. The equivalent capacitance of this bottom branch is 12. The battery behaves as if this thing was a 12 microfarad capacitor, so it's going to shuttle 60 microcoulombs across it. And that's only one place for it to go over here. this plate right here. So this has to have 60. And the 60 is going to split, which means these guys will each get 30. So this guy must get 60 microcoulombs of charge. Every capacitor in here is 30 microfarads. So it's going to split, and each of these will get 30 microcoulombs. The voltage drop here is 60 microcoulombs divided by 30 microfarads, which is 2 volts, which is what we want. Hallelujah. This guy has 5 times the charge. So I think this is the answer to the problem right here. Let's keep going. What is the charge separated by each of these capacitors? Has to be 30. The 60 gets split in 2. And there's a domino effect. The battery only has access to this guy, this guy, this guy, this guy, and then these 3 plates on the other side. And then there's this domino effect of the charge shifting in between. The 30 microfarad capacitor, these guys that separate 30 microcoulombs of charge, each have a voltage drop of 1 volt. And I think we have it all. So let's look at a big diagram. Okay, there's our circuit. There's our battery. We're going to hook up the battery. Charge gets separated. These are all 30 microfarad capacitors individually. This guy's right across the battery. He gets 5 volts. And hence 150 microcoulombs. This guy's 1 volt, 30 microcoulombs. So is this guy, so is this guy, so is this guy, and this guy, as well as this guy, and this guy, and this guy, and this one, and this one, and this one, and this one has 2 volts and 60 microcoulombs. So we can check that the charge sucked from one side, it's 150 and 30 and 60. That's 240. The battery pushed it and it ended up here, 30, 30, 30, and 150, which is also 240. And any path you take from one side of the battery to the other, the total voltage drop is 5 volts. 1, 2, 3, 4, 5, and back to the battery. We can go through this branch and get 5 right here, and there's nothing else all the way back to the battery. Go through this branch, 1, 1, 1, 1, 1, and back to the battery. That is the right answer. That's a hard problem for problem number 1.